whenever we want to bound the probability of union of events, one of the very useful and simple bound is this union bound. This should be your first attempt at giving an estimate of this probability, the probability that any bad event happens, or probability of union of AI. Let me take an example where this is going to be important. The example is of a random graph. You are familiar with a graph, right? These are the graphs which you studied in CS 201. They had vertices and edges, right? We can even create a random graph. What is GNP? This is a random experiment where you pick every edge with probability P. N denotes, what is your guess? N denotes?
Number of nodes.
Number of
vertices. Yeah, it's an undirected graph. You have n vertices, and then in the random experiment, you pick an edge with probability P. With probability P, you will pick it, otherwise you will discard it. And then you are interested in, is this graph well connected? Is this, what kind of properties are there? Does it have an isolated vertex? And things like that. That is the kind of questions you consider here. These are called Ardos-Renyi graph, but anyway, not very important for you to know these names. Now, if I describe to you this random experiment, our first thing, as always, should be to figure out the sample space and the probability distribution function. So can you tell me what is the sample space here for this random experiment?
Set of vertices.
No.
Set of edges, sorry. Set of edges.
See, what will a set of edges do? It will specify a particular graph, right?
Yeah.
But once you do a random process, right? You pick some edge with probability P, some edge with probability B. Finally, what will you end up with? You will end up with a graph which will have certain edges and certain edges will not be there, correct?
Yes.
So then, what are the all possible distinct outcomes? What is the sample space?
A graph with all vertices connected with every other vertex.
That will just be one possible outcome, right? Of this random
means one vertex will connect with every other vertex. Similarly, all other vertices will be connected to each other.
So that will just be one possible outcome of this random experiment. When you pick this edge also, when you pick this edge also, when you pick this edge also.
Sir, power set of edges.
Yes, yes, you are getting close, or other way to say it would be set of all graphs on n vertices, right? So yes, it is not that easy to figure it out, but now once I tell you, now you see that what will this random experiment result? It will result in some graph. It might have one edge, two edge, three edge. It might have an edge between vertices 1 and 2. It might have a edge between vertices 2 and 3. But yeah, so set of all subgraphs, that's close. But yeah, to be precise, it should be set of all graphs on n. Finally, you will end up with a graph when you perform this random experiment. Remember, what is the random experiment? You look at first edge, you number the edges, 1, 2, 3, 4, up to. How many edges will be there?
Also, n into n minus 1 by 2.
Yes, and choose 2, right? And then you say, oh, first edge, do I pick or not pick? That's the randomness here. Second edge, do you pick or not pick? And if you keep doing this for n choose 2 edges, finally you will end up with a graph. That is your possible outcome of this random experiment, right? And that's why the sample space is the set of all graphs on n all possible graphs on n. And as someone said, you can think of it as subset of edges, because each graph corresponds to one particular subset of edges. So you have these, this is the size of your set. Is there any question here? Is it clear?
Sir, I have a doubt. You said all AIs to be bad event. What is the meaning of it?
No. That was so that will come now. That will, I'm saying intuit. See, when I say probability or union of AI is less than PA1 plus PA2 plus PA, that's just a set notation, right? That's a set property. We don't have to worry about what is A1, what is A2. For any sets A1, A2, AN, this union.
Yeah.
Right?
Yes, sir. But you use the word bad event. That's
So
why
I'm saying intuitively, most of the time when you are going to apply this bound,
yes.
it will be used in this kind of a framework where, you know, AI will be some kind of a baddie, and you want to bound the probability of having only good events.
Okay.
And last time, you remember what was AI? Like, we wanted to find a probability when no letter goes to the correct answer. And then
No letter
AI
goes
was
to
the
the.
correct answer,
Oh, okay.
right? And then
Yes.
AI was the bad event that ith letter did not go to the correct. Ith letter went to the correct answer.
Yes.
So this AI being a bad event is just an intuition. This is how we will mostly use this. And you will once again see the application.
Okay,
Okay.
sir.
But before that, let's fix our experiment. Let's be clear about what is the experiment. So now if the sample space is there, what is the probability? So probability means if I pick a particular graph, let's say this has n vertices, and let's say I pick a complete graph, okay, on n vertices. What is the probability of obtaining that graph? I want a probability of every element in omega, right? That's my probability distribution function. What is the probability of G?
1 by 2 की power NC2.
Okay, very close. Why did you say 1 by 2?
This is only one possibility of all obtaining all.
No, but why
edges.
did you take it half? Why was it not 1 by 3?
Sir, in power set we have 2 to the power NC2 total number of possibilities.
But did I say that I am picking an edge with probability half? What is the
No, sir.
probability, right? What is the probability that I pick an edge?
Sir, half if unbiased.
No. So if I hadn't specified it, then you could have assumed it to be half, but I have specified it in this case, right? So you are right, but you just missed one small thing, right? What was the probability of picking an edge? It is written right here,
P.
right? So remember, again, it intuitively, because the way you have looked at high school, you always take things to be equally like. But now we are not in that domain. So now if you know that we pick every edge with probability P and we have picked n choose 2 edges, then what should be the correct answer? What should be the probability of G? Like a complete graph? Instead of half to the power n choose 2, it should be
1 by P to the power N choose 2.
not 1 by P, P to the choose
Means
n.
P. Sorry, sir, P to the.
Yeah. Yeah, but you are absolutely correct, right? You have got the intuition, right? And so this was for the complete graph. What if my graph is not complete? Suppose my graph has E edges. G has E edges. What will be the probability of G? That means I picked E edges and I did not pick n choose 2 minus E edges.
P to the power E.
And
P to the power E.
1 minus P into 1 minus p की power and choose 2 minus c.
Very good.
Yes, sir. Yes, sir.
Right? And this should not be surprising to you. Let me tell you in simply, since it was in graph language, you probably took some time. I have a string of length n choose n choose n by 2, okay, of heads and tails. The probability that I get head is p. The probability that I get tail is 1 minus p. What is the probability that I obtain this sequence if number of heads were equal to e? You see the question? It is exactly parallel to this kind of a. You have a sequence of head, tail, head, tail, head, tail of length n choose 2. Probability that I obtain a head is p. Probability that I obtain a tail is 1 minus. If I tell you that my sequence has e heads, what is the probability of the sequence? Is the question not clear? Should I repeat the question?
Sir, 2p into 1 minus p.
No. 2p into 1 minus p.
Yes, sir. I said same.
No. You have a string, right? Okay. What is the probability that you get head, tail, head, tail? When you toss a coin 4 times, what is the probability?
P square into 1 minus p ka whole square.
Very good. Now, if you know that number of heads is e and number of tails is
N minus e.
n choose 2 minus e, right? The length of the sequence is n choose 2, right? So then the probability would be
Yes, sir.
p to the power
P.
e 1 minus p to the power n choose 2 minus. Right? So this is the probability distribution function.
Sir,
Mhm.
the E edges that we are removing, like we are not considering them, are they fixed or like we can choose any E edges?
No.
Because like
I was talking about a graph where a particular set of e edges are aligned.
oh, okay, it is particular. Okay.
Yeah, because remember, that is why I said what is the size of your sample space, which is 2 to the power n choose 2. So all possible subsets, right? To take this case, I think this is the question which you are asking. These two graphs are different, right? For this also, the probability is p 1 minus p whole square, and for this also, it is p 1 minus p whole square. These are two distinct outcomes. If n was 3, and I was picking every edge with probability.
So sir, our event have like one of them only, like not all such cases.
I'm not at all talking about events to start with. First of all, I have to describe the probability distribution function, right?
Oh, okay.
Right. So this is what I have done. Now, once I have told you the probability of every single element, right? Remember what was p? It was the function from omega to r. And now I have done that. Now we can talk about taking, so you are right, you can think of them as events with single element, but that is the first thing which needs to be specified. Once I have specified it, I can talk about probability of events. And this is what this question is. And remember again, I don't want an exact answer. I just want an upper bound. What would be the bad event here? what would be AI is here, right? I want to, GNP has an isolated vertex. If I call this event A, I want to write it as A1 union A2 union A. So probably this is a better way to put it. What should be AI here?
So the vertex I is isolated.
Yes. Very good. And what is the probability of AI? Now this you should be able to figure it out. Vertex I is isolated.
1 minus p to power 1 minus n minus 1.
Very good. Right? Again, if there are questions here, please ask. Okay. And then, so then what do I know? The probability of A or probability of A1 union A2 union AN, this is less than equal to,
N into 1 minus p raised to the power n minus 1.
right. So I already get a preliminary bound on this probability of having isolated vertices. So the bad event that I have an isolated vertex happens with probability at most n1 minus p to the power n. And you might ask, why is that useful? Why didn't I apply inclusion exclusion? Because this will already tell me things. For example, if p is around log n by n, so this is a very, very small number, right? Log n by n. And already I will say that the probability of having an isolated vertex tends to 0. This is simple math, which you can try it. If it is not clear, I can tell you on hello. But the consequence of this was that just by applying the union bound, not by calculating all the inclusion, exclusion, doing complicated things, we already had an upper bound on the probability of the bad event, the probability of GNP having an isolated vertex. And then we can talk about, okay, you know, if my, even if my P is slightly big, then with very, very high probability, I will not have an isolation. You can make these comments. Okay, this is how union bound will be used in future. This was just one example, but the point to emphasize is many a times you don't want to calculate this union probability exactly. Just looking at the PA1 plus PA2 plus PAN is a very, very decent bound.
Sir, can you explain that probability of AI?
Probability of AI, yes. So what is the event AI? Event AI says vertex I is isolated, right? So let's say, and this is vertex I. Should I say? Right. So except I, how many vertices are there?
N minus 1.
N minus 1, right? If vertex I is isolated, that means I comma 1 is not present, I comma 2 is not present, I comma n is not present.
Yes, sir.
What is the probability that I comma 1 is not present?
1 minus p.
Right? I comma 2.
Okay, 1 minus p.
Right? And there are n minus 1 such. So there is a small assumption here which you probably make when you do solve questions on probability. We will go about that. We are saying that, you know, when we pick this edge, that event, that thing does not affect the probability of when we pick the edge I choose to. They are totally independently decided. This is an assumption which you have been making, and that's why we have multiplied the probabilities here. But let's not worry about it. This is something which we will consider in third and fourth, and it will be clear that why we could make that assumption. Okay, but that's something which we'll talk about in third. Okay? Let's not worry. But this is clear, right? That I choose one, I comma 1 is not an edge with probability 1 minus p, I comma 2 is not an edge with probability 1 minus p, and so on. There are n minus 1 such things. So the probability turns out to be 1 minus p to the power. Right? Okay.
So can you explain how you got P approximately equal to log n by n?
No. The statement is if p is approximately log n by n,
Okay,
it will imply that this probability is tending to zero.
okay,
And there is no probability involved here. This is just mathematics, right? This is using
Yeah.
the fact that 1 minus 1 by p whole to the power p tends to e or something. Okay, so this is just limits and everything which you did in your first year. But if there are confusions about this, we will take it on, and I can explain to you how this kind of a thing could be. Okay, so that's good. We did PA1, A2, AN. Everything is fine. But what if sample space is infinite and continuous? And again, this is not going to be the main focus of this course, but still, I want to just make sure that we know about this. And this will be useful in certain cases. Right? So let's take a random number. Let's take a random example. The experiment is you have this real number line, right? Which has numbers from 0 to 1, and you hit a dart, it gives you a real number, and that's the outcome of your random experiment. We want to figure out what is the probability that r is less than r. What do you think is the probability if I hit the arrow
It
uniformly? Huh?
It seems half. It seems half.
It seems half, right? And that's what we want to figure out. But now let's go through our framework, right? What is the sample space here?
Set of all real numbers.
Set of all real numbers, or
0 to 1 in between.
yeah, set of all real numbers between 0 and 1. Great. Now, what is the probability? So now this has infinite points. Let's pick a particular point, particular real number r between 0 and 1, or call it something else, a. A is a real number in 0 to 1. What probability should we assign? You see a problem here?
Almost zero for any particular real number.
Right, right. So you see the problem here, right? That if I assign it a non-zero probability, then the total probability will go above
Infinity
above
means
not
one
just one.
above one.
Above 1, above infinity. You are right, above infinity, right? We wanted it to be equal to 1, it will go. But if I assign it to be 0, then the total probability is
Zero.
0. So we want to model this kind of experiment from our framework, but our framework is not sufficient. How we will solve it? We will change our framework, but that comes later. Before that, is it clear that this is a problem in our existing framework where we only talk about omega and probability distribution function from omega to r? In this simple framework, we are not able to take care of this random experiment where sample space is infinite. Is the issue clear?
Like
Yes, sir.
if we don't write in terms of number, like we write in terms of variable, like number of real number between 0 to 1, like probability will be 1 by number of real number between 0 and 1.
Okay.
And then we will proceed. Then it is also a problem. Like
Okay. So did you learn about countable and uncountable numbers?
Yes, sir.
raised to 0, 1. The number of real numbers between 0 and 1 are
Uh,
uncountable, right?
yes, sir.
And even before that, even in the sense, even if the numbers were countable, 1 by infinity does not make sense. Infinity is not a number, it's a symbol, right? So you 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 think by keeping it as a variable, everything will be fine. But what if I say what is the probability of two, let's say probability of A or B, two real numbers, and then you will say 1 by infinity plus 1 by infinity. I don't know what that means. There is no addition defined. See,
Oh, okay, sir.
in the
Yes,
case
sir.
of countable, you could have done this kind of a thing that, first element has probability half, then 1 by 4, then 1 by 8, and so on and so on. But now the number of elements here are uncountable, and this is a big problem, right? So now, how do we take care of this issue? We change our framework. Okay, sorry that I introduced a framework only last class, and now I'm changing my framework. The point is that most of the time we will be concerned with the framework of last lecture, but we should know that it is not all encompassing. It does not take care of all the things, especially when your sample space is infinite or continuous. Then we have to tweak our framework a little. And the main observation there is that only certain kind of events are interesting. It's not like everything is we do care. So remember, it was, even if you didn't, some of you did not speak it, it was clear to you that this probability should be half. The probability that I pick a random number less than half should be half. So if we are interested in only this event, why should I care about probability of A? I don't want to. I just want to define probability only for certain events. Only certain kind of events are interesting. You can call it a trick, you can call it an intelligent solution, but now in this new framework, remember what were events before? Events were a subset of
Sample space.
sample space. So they were coming from all to the power omega. And now I am saying I will not define probability of everything into the power. Not all events in to the power omega are interesting. That means there might exist s element of 2 to the power omega such that probability of s is not. I don't care. I will not worry. Okay, this is the change. I will formalize it, but this is the intuition. Some of the events I won't care what is the probability of this. I will not allow you to ask the question, what is the probability of a simple error? Okay, and then if not all events into the power omega are interesting, but then we have to be sane. We can't say that you pick, you can only define probabilities of some particular subsets. In effect, if if you talk about A, then you should talk about the probability of A. If you talk about A and B, then you should talk about the probability of A. These should make sense. Otherwise, your random experiment, your probabilities will not be very useful. You will not be able to do much with this probability. And this kind of an intuition gives you the idea of sigma algebra. Sigma algebra is going to be the set of interesting. Okay, so let me define what is sigma algebra. Any sigma algebra, so this is going to be a subset of 2 to the power omega. This is going to be some set of events, not any set of events, but they should be nice. What is the probability or what is the property of sigma algebra? The complete set should be in sigma algebra. If A is element of S, then F, then A complement is element of F. This is basically showing that empty set is also an element of my sigma. And countable union of sets, not just A1 intersection A2, but A1 intersection A2. Sorry, A1 union A2, but A1 union A2 union A2. Even A1 union A2 up to a countable union, even these should be part of the sigma F. If any subset F of 2 to the power omega satisfies these three properties, I will call it a sigma F. Okay, so and then the most important change now is that my probability distribution function will be from F to 0. Notice a change here. What was the probability distribution function before? It was a function from
Sigma.
Omega.
yes. So instead of omega, now we are saying that we are only interested in certain kind of fields. That will only make sense. But the function should satisfy same property. You cannot just pick any function. The probability of the complete sets should be 1. That's the normalization. That's what we believe in. That probability of everything should be 1. And if A and B are disjoint, then probability of A union B is equal to PA. So let's just compare what we had before.
Sir, I have a doubt regarding the
Sure.
previous question which you gave.
Sure.
That this our the main set sample space was 0 to 1 closed bracket. But what if we have a question when we need to find the probability of the event such that it is from 0 to 1 open brackets? Then is that event an interesting event?
So at this point, I haven't defined my sigma algebra, right? At this point, I'm just changing my framework.
Yes, sir.
Let me change the framework, and then we will see that the open interval will actually be.
Okay, sir.
Okay, but let's just make sure that we know the framework. The example of the framework will come next. Okay, and so now remember, old framework, new framework. How did things change? What was the old framework? I had a sample space. What was the probability distribution function? Or let's say, what were the events? Events were element of
Subsets of sample space.
2 to the omega, right? And then my probability function was specified from omega. And we should keep this in mind because this is going to be useful in 99% of the cases for us. So don't forget this. But we should remember that there are some cases where this old framework is not good enough. So what is the change? We again have a sample space, but then events are going to be some element of some sigma algebra. You can read about it more. I don't want to go into the detail because this case we will encounter not that many times. But there are some small simple properties of sigma algebra. These are some F is a subset of 2 to the power. These are going to be events. And then my probability is going to go from sigma algebra to, okay, I should say just 0, 1. That's it. My probability is going to given some number between 0. The small minor changes that we are saying that our events need not be the complete power set to the power omega. They could be a subset of to the power omega where the subset satisfies some properties. What are the properties? The properties of sigma. Even if you are not clear about the sigma algebra properties, don't worry about it. most of the time you will hear about just one kind of sigma algebra, which we call oral sigma. Okay, it is the smallest sigma algebra containing open. So now when my sample space is 0 to 1, I can define F to be, this subset of 2 to the 0 comma 1, where open intervals, their complement, and countable union of these sets, everything is in. So it's not easy to tell in one line what are the exact sets which are present in this sigma algebra, but are interesting things will be fine. Okay, the kind of things, the kind of questions you were asking. If I pick a random number between 0 and 1, is this, what is the problem? Once I tweak it, I say that this is my F. Now, you remember the question between 0 and 1. Now, if I want to describe the probability of an interval, intuitively, what should be the probability of an interval?
Length
Upon
length of
Exactly. The probability of interval should be proportional to the length of it. And since now I'm taking the 0 to 0 comma 1 interval to have probability 1, the probability of interval will not be proportional, but it actually will be equal to the length. And this is the most useful sigma algebra you will require in the continuous case. If you go into a mathematics course, they will tell you about properties of sigma algebra, things and everything. But for us, we don't need to go into that detail. If you are interested, I encourage you to read about it. But for us, just it is enough that there is a new framework, and for us, we will mostly care about the sigma algebra, which contains all the open. Notice it is not the set which contains only the open intervals. It has to be a sigma algebra, so it has to take the complement, it has to take the countable union. Okay, but in some sense, we create the smallest sigma algebra, which has all our interesting events. Okay, so but once we change the framework now, remember this is something which we had proved before. Now, how will we prove this? Remember, we only know that probability of what we know is just two things. Probability of omega is equal to 1, and if A and B are disjoint, then probability of A union B is equal to PA plus P. We can't say that, this is summation over W element of A union B, P of W. Why can't we say this?
because of continuity, means now events are continuous.
Right, because of continuity, but in this particular framework, P omega might not be defined.
Yes.
Right, we have said that not all events are interesting. So in particular, probably P omega is not defined. Then what does this quantity mean? So now, how will you prove such an equation? So now P of A union B equal to PA plus PB. That means event A is in your sigma algebra, event B is in sigma algebra, A union B is in sigma. All these events are interesting, their probabilities are different. What we know is if A is interesting, then A complement is interesting. And just by these two things, what should be the probability of A complement?
1 minus probability of A.
1 minus probability. So everything will follow quite naturally, like you would want it to be. But it requires a slightly different. So now, how will you prove this? How will you calculate probability of A union B? Can you write A union B as a union of 3 sets which are disjoint?
Here.
Yes. How? A intersection B complement, union A intersection B, union B intersection A complement. Is that okay?
Yes, sir.
This method.
Right. But what is the guarantee that A intersection B complement is part of the sequence?
Because it contains open intervals.
No. So that was one example, right? That open interval was just one example. But remember the old definition. If A is there, then A complement is there. If A is there, then A union B is there. Sorry, A comma B are there, then A union B is there. These imply if A and B are there, then A intersection B is also there, right? Remember De Morgan's law?
Yes, sir.
Right? So all these interesting sets are also there. So if A and B are there, then B is there, that means B complement is there. If A and B complement are there, then A intersection B complement.
Rajat, there's a question in the chat.
So because in the new framework, we do not have probability of W, right? If you were in the discrete case, you could use the old definition. You could say that P of A union B is summation W element of A union B PW. And you can prove this. But now, if your sample space is infinite, your proof is not valid. That is why we have to use the new method to prove.
So the A and B can be intervals also.
See, A and B could be intervals when your sample space is an interval. But at this point, they are just some subset of the sample space. Right?
Okay. So
Sir,
we
Remember,
be interval if A and B are not interesting.
if A and B are interesting, then we are talking about probability of AU. Yes. So it is
Else it
given
is
that,
not defined.
sorry?
Else it is not defined if A and B are not interesting.
Yeah, because then the numbers here, right? P of A, what do you mean by P of A? So then this equation is not well defined. So we don't need to prove it when P of A is not
Yes.
right. So
sir, we have not talked about intersection. Then how can we solve this?
right. So this
That-
is what I was saying, that since union and complement is there, then we have intersection, right? What is A intersection B complement?
A complement union B complement. Yes, sir. Yes, sir.
Right.
Got it.
Got it?
Thank you.
So right.
Yes, sir.
So actually this is why we created sigma algebra like that, so that every interesting kind of a set, functions of sets would be there. And now your A union B is an intersection of these 3 sets. And what is the probability of A intersection B complement? In terms of P of A, can you see that this is PA minus A intersection B complement is this?
PA into PB.
No, that requires much more assumptions, but
P
A
minus
intersection B.
P of A intersection B.
P of A intersection B, right? And similarly, P of B intersection A complement is Notice this is coming out because A intersection B complement and A intersection B are disjoint. That's why we can write this from the assumptions on probability distribution. Now, noticing that even these three sets in A union B are disjoint, I apply my formula and I will get this. Again, you will not be needing to prove these things formally most of the time. I just wanted to emphasize that just the assumptions which we made about sigma algebra and probability distribution function will allow us to prove these properties which were immediate. This
Excuse me,
process.
sir. So what is the need of the two sets being like the A and B being disjoint here? If we are proving it for, like, we can show what is the probability of A intersection B.
Because that's the only assumption we are given about the probability distribution function. If you look here at the bottom, we are only given the probability of A union B when A and B are disjoint. That's the only assumption we made about our probability distribution function. You have done abstract algebra, right? You have done groups where we take some basic properties and decipher more and more properties, right? It's the same thing which we.
But my question is that if we are like in a latter half, we are defining the probability of A intersection B. So why are we considering, like, if we can define the probability of A intersection B, why we are at this stage while taking an assumption, while we are taking an assumption that A and B are disjoint? So like here here also in A union B, we need an A intersection B. So we are able to define that.
So first step is to find out that probability of A intersection B makes sense. Correct?
Yeah.
And that, so actually in this formula it is given. So we can assume that probability of A intersection B, but let's say probability of A intersection B complement. Is it going to be there for us, or probably there might be a situation where this probability is not defined?
Okay.
That's the first step. Once we do that, once we know that these probabilities make sense, then we can prove R. Otherwise, how will you prove the first equation, the one which you want to prove? What is the idea?
Yeah.
Right, because we don't know this equation from just the basic assumptions we have.
Yeah. Okay, thank you, sir.
And before we leave, just one last question. What is the sigma algebra for our easier definition? What is F in our old definition, right? What were the set of all interesting events?
Like power set of samples.
Exactly, 2 to the power. So the old framework is a subset of the new framework. Right? They might look different, but old framework is just when I say that my sigma algebra set of interesting events is the power set of samples. Okay, so new framework is kind of stronger in the sense that it subsumes old framework. It's slightly more complicated to apply. If we need to, we will use the new framework, but if we can get away with applying old framework, we will use the old. Okay. So this is the way in which you can mathematically model probability, and you might again ask, what is the issue? And in the next class, we will look at this question. You remember, this is something which I asked in the first class. What is the probability that a random chord is larger than the side of this inscribed equilateral triangle ABC? And all of you got different answers: half, 1 by 3, 1 by 4. And essentially the crux is going to be that we are in different sample spaces. Our sample space is different. If the set of interesting events are different, then we will get a different answer. for us to make this, for this question to make sense, we should be careful about how we describe the sample space. Then only we can talk about this. But that's going to be a topic for next week. That's what we will see. For now, just one more thing. There is going to be a quiz, a small quiz on Monday. Remember, I said 6 quizzes. This is going to be the first quiz. It is going to be objective on hello. It is not going to be difficult. What I want is that all of you look at the lecture notes or videos and are just familiar with what we have done. Okay, just to make sure that you are looking at the content. That's the intention. That's all from my side. Again, sorry for being slightly late. Let me know if there are any questions. Otherwise, please feel free to.